Hey, Science 10. So in this video, we'll be looking at climate change and its cause and some of the effects it's going to have on Canadian biomes. Now, one of the great Canadian biomes is the taiga, or boreal forest, made up of coniferous trees. I've got one right here beside me. Coniferous trees have cones, and of course, they've got the needles. You might think of them as a classic Christmas tree, basically. And essentially, trees like this with their needles, that's their leaf actually, and of course they're conducting photosynthesis right now in the summertime. I'm actually not in a boreal forest, but this is indeed the type of tree that you would find in a boreal forest. And yeah, again, we'll look at the causes of climate change, and we'll look at some of the effects it's going to have on Canadian biomes. And one of the big Canadian biomes is the taiga, or boreal forest. Okay, see you in a moment.
All right, so we were just taking a look at one of the great Canadian biomes, the taiga, or the boreal forest, made up of coniferous trees. And yeah, we're going to look at climate change due to greenhouse gas emissions, how it's happening, and its effects on Canada, specifically Canadian biomes. But ultimately, greenhouse gases trap heat in the atmosphere. The Earth is quite different from the moon. You've heard me say that before in other videos. You got water, vapor, natural greenhouse gas. That's not a problem. It's the ones from human activity. These are good at trapping heat. A reminder, oxygen and nitrogen don't trap heat. So this is what causes heat to be trapped. This is what causes our climate, is the greenhouse gases. You see the sunlight energy coming in. Some of it bounces into space, but some of it bounces back and gets trapped. And ultimately, it's the vibration of these molecules as they get heated up. They start vibrating and they start releasing heat because they've been heated up, and they continue vibrating once heated up. You know, for a while, eventually they would cool off. But yes, these gases do indeed trap heat. So here's what's happened to global temperatures in the last, well, since climate records about the 1880s, 1860s. Consistently show global average temperatures going up and up and up. So definitely global temperatures, the climate is definitely changing. And when we compare that to the change in CO2 level, you will see these two graphs are very similar. They're both going up. So carbon dioxide levels are going up, at the same time temperature is going up. We know that CO2 gas traps heat. A reminder that the structure, it's the very structure of this molecule that as heat energy hits it, it starts to vibrate, and it continues to vibrate, I mean, until it cools off. But similar to a pot of water, it'll hold heat for a long, long time. In fact, water vapor, H2O, can hold a lot of heat as well. But of course, this is to do with natural climate natural sources for warming the climate, whereas this one is put in by human beings, and we can see the amount of carbon dioxide going up, and we can see the temperatures going up and up. So it's really those two pieces of evidence which points us to it's human-caused climate change. All right, so where's that coming from in Canada? 28% of CO2 emissions and other greenhouse gases, but CO2 is definitely the main one, is from transportation. 28% of it, 45% of burning fuel for electricity. So again, you're going to be burning methane, you're going to be burning propane, you're going to be burning octane, it's called in our cars, and that's all going to release CO2 gas. Methane would be another powerful human emitted gas from industry, from all of these activities would definitely release methane. And so would dinitrogen monoxide, or also called nitrous oxide, particularly from agriculture, this one. But ultimately, CO2 is the biggest problem. So that's where it's coming from. Here's the changes to the biomes. We won't take a look at tundra, but that's up in the north here. You can see by the color where the tundra is. The taiga you've already seen at the beginning of the video. So the boreal forest made up of coniferous trees. Let's do a quick look at deciduous forest. So as you can see, the deciduous forest is full of leafy trees. Let's take a quick look at grassland.
So here we have a grassland found where there's lots of sunlight, not as much water, and so yeah, generally a warmer biome.
As you can see, the grassland is grass. We don't have a video of desert, but this is actually around Kamloops. There's very, very little desert in Canada, virtually none. I mean, there's a few pockets in BC basically are considered true desert. But if CO2 levels double, and we do project this potentially by approximately 2100, so that's in about 80 years from now. So it's about, let's say it's 2020 right now. 2021 actually is what it is right now. And if CO2 doubles, then definitely the atmosphere will heat up. Ultimately, when there's little solar energy and not much heat, you don't get much plant growth. But as it gets hotter and hotter and hotter, it gets drier. So this is when it's hot and dry, a desert. Let's just say very hot and dry. This is just hot and dry. This is sort of warm / hot. It's a little bit dry, this kind of climate. Whereas this is just warm, cool, there's more water. So ultimately the projection is for a lot hotter and a lot drier changes due to climate change in Canada. Okay, take care, Science 10.